Okay, I'm right back. I took about a 3-second break. One thing is these videos can't be too long. If the file size is too big, YouTube won't take them for free. So I limit them to about 14 minutes, and I'm safe that way. So it's good. It makes sure you don't just watch too much of it. So I have one more. Yeah, so it's a couple more examples. So suppose I have example. Suppose I have on the shelf, this is true actually, so currently have on my shelf to get ready for school 5 linear algebra books, 2 probability books, and 1 multi-variable calculus book. Okay, A. If I want to arrange them linearly, like on a bookshelf, how many distinct linear arrangements are possible? Well, you remember 5 linear algebra, 2 probability, 1 multivariable. So the answer is if I can mix them anyway, and I do care left to right, right to left, say, then it's just all the ways I can put the leftmost one, which is 8. So the solution is just 8 times 7 for the next, because for each of these there are 7 left. 6 dot 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 down to 1. This is 8 factorial. Okay, I don't know what that one is off the top of my head. Next, suppose now B, how many arrangements if each subject must stay together, must be together? Okay, well, now I need the 5 LA books. So there's 5 of these. And now 2 probability. And then there's the 1 MV here. So how to do this one? Well, if they have to stay together, these have to all be together. So probably the simplest way to think about this is as a hierarchy. I can arrange these any 5 ways, any 5 factorial ways, these any 2 factorial ways, this only 1 way. But then I can also arrange the boxes. So there's 3 boxes, so there's 3 factorial ways to arrange the boxes. So my solution is that. It's 5 factorial times 2 factorial times 1 factorial times 3 factorial. Okay, for the ways to arrange the boxes. It is principle of counting, right? Because within each box, I'm applying the principle of counting, and then overall, I'm applying it. Now, could you do it, say, in a more direct way and say, well, there's 8 possibilities for the first? It would be very confusing to do that, right? Because then you would have to think about conditionally which the first one was. So this is, I think, the better solution. Okay, I wouldn't try to do that directly, although sometimes you can do that too. I wouldn't do it here. So what fraction is, say, B over A? How rare is it? Say you were to ask a small child or a chimpanzee or somebody that really, say, couldn't read, to arrange the books. What's the probability they were all together? I'm not trying to denigrate small children or animals, but what fraction is this? Might be interesting. So we could look, say, 5 factorial, 2 factorial, 3 factorial. I can drop the 1 now, over 8 factorial. And there's like all this cancellation that goes on. I think that's why I wanted to do this. So I have 2 factorial, 3 factorial over, down here I just have 6 times 7 times 8, right? 6 is 3 factorial. So the answer is 1 at 28. Okay, so there's a 1 in 28 chance if you were to do this randomly, completely randomly, that they would all come out together. Okay, new idea. How many arrangements are there of the word, of letters in the word puppy? Okay, well, clearly this is a little different because if I pick, let's say the first one is P, and then I take the next one to be P, that doesn't really look any different than if I took, say, this P and then took that to be P. So the approach to thinking about this, I think, the best one, is first to make these distinguishable. So let's first answer the question, answer same question for the word puppy with subscripts. Okay, you could actually start to write your letters like that with subscripts when they repeat in the same word for your other classes, okay? It's okay. So this is easy, right? This is 5 because they're all distinct. And then so for each choice of the first one, there's only 4 for the next. So this is 5 factorial. So answer is 5 factorial, 120, right? But now I have to keep in mind that say, for example, but, say, P1, U, P2, P3, Y looks the exact same way. It's no different once I take the subscripts off as P2, U, P1, P3, Y. So since I don't care about this with the silly subscripts, I care about it when the P's are indistinguishable. I have to somehow correct this. So what's the way to correct this? I have to count how many there are like that, right? Well, since there's 3 P's and they're all the same, there's 3 factorial ways to arrange them. I can have the P1 here, P2, P3. I could have P1, P3, P2. So I have 6 in this way. So probably the smartest thing to do is to think of it as a long list of 120 different distinct arrangements with the subscripts, but then realize that I'm over-counting by 6 for each one. So I want to divide by 6. Okay, so since there are 3 factorial arrangements in P1U, P2, P3Y for each arrangement in the undistinguished one, we divide by 3 factorial. So solution is 5 factorial over 3 factorial, which is just 20. Okay, so if I were to list this one, which I don't want to do, it's a little long, right? There's 120 of them. You would see 6, which essentially would correspond to this. For every corresponding one, for P, 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 U, Y, everyone would have 6 possibilities, okay? So 6 possibilities for each possibility here. Okay. Okay, so there's actually a formula for this. You could have more, so in general, so we could write this as a little result. So I'll call it a rule. If we have with n objects of which n1 are indistinct, indistinguishable, and 2 and r such that n is equal to n1 plus n2. Right, so, sorry. So if I have n objects, but I have these groups of them that are indistinguishable. So for example, in the puppy example, I had n1, say, is 3, n2 is 1, n3 is 1. So then there are n factorial total, and then I divide out all possible permutations there are of them. So on the bottom, I divide out n1 factorial, n2 factorial, dot, 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 and r factorial. Okay, there are this many this many different arrangements. Distinguishable arrangements. Just to be clear. People might not write that. Distinguish. It's a long word. Okay? All right. As an example, compute how many arrangements of Alabama. Okay, we gotta stop. I will be back in a minute.